distribution plot. Distribution plot is nothing but your histogram. Okay, distribution plot in in PLT matplotlib it is distribution plot, and in CBON is called distribution plot. Okay, sorry, histogram is called in matplotlib and distribution plot here in SNS. So it takes the data and it plots a bar graph. Okay, so you are creating so histogram. What do we need? We need number of the values, right? Range, correct? So we create the range. You get this. Now you see here. Now when you look at any data, for example, okay, you expect the data to be something like this. It's called bell curve. What does it mean? Most of you would have heard about the bell curve. It means, okay, when you have a data, this is normal, okay, and this is also your mirror image, okay. So the area this side is same as area this side. The middle line, okay, is equally dividing this bell curve into two halves, okay. And in this case, your mean, your median, and mode will be on the same line here. Okay, so we go from left, right, right, x value 5, 10, 15, etc. Whatever falls here, this is the mean value or median or mode. All these three are same. What does mode means? Maximum occurring, right? In histogram, this is nothing but maximum occurring, isn't it? It tells you how much. Remember that Bangalore and Bombay example that we did, right? Rental yield. Okay, it tells you how many, right? So of course this hump is always your mode. Hump is always your mode. Remember in Excel with the first example 1, 2, 2, 3, 3, 4, 4, 5, 5, right? And then again we decrease. So that's the normal data. In normal distribution, and when you put a continuous data, okay, we call it as distribution. Okay, so you get a normal distribution here. That means data is equally, distributed with respect to center, and center is your median mode. All are same. Okay, so when you take large values, okay, you will get something like whether you take weight of all individual, height of individual. Okay, you will end up getting something like this. Okay, there will be very few people with very less kg, like 20, 30 kg. If you talk about adult male, let's say 18 plus. So 20, 18, there will be 1 or 2, right? There will be 1 or 2 people with low weight also. And extremely high, like 140, 130 kg also, you'll find few people in the population. But bulk will be maybe, let's say 70 to 80 kg, let's say. Okay. So this is where bulk of the people will be there, and mean, median, mode, all are same. But what if, okay, if there are more people with higher weight, 200 kg, 300 kg, 400 kg, and of course this will be very less. Okay, you won't get a big this thing. Probably you will get, something like this. Okay, this we call it as tail. This is your tail. Okay, this is also tail. So when you see this, compared to left side, your right side tail is going towards right more. Yes or no? Yes or no? Important concept,
yes, sir.
Right?
Yes, sir.
That's not sleeping or what? I have to call and I have to phone everybody and ask, did you understand on the Zoom? Did you understand on the Zoom? Did you understand on the Zoom? There was sir, sorry sir, my laptop is at home, I'm in the bus. Sorry sir, I did not listen to you. I was having my breakfast. Please listen. Okay. So what happens when you add extra value on the right hand side? So see, when you add, so till here it is normal. But there, of course, there will be some values which will go added. Okay, let's say you find somebody with 200 kg, 190 kg, 210 kg, 300 kg. Okay, so you will see this tail is bigger compared to this side. Correct? This side is small tail. Here you have a much bigger tail. Correct? Yes. So this is okay. Now, if you look at axis, this is your x-axis. Okay, so when you look at axis, okay, and positive, negative, which direction is this? And which direction is?
Left is negative, right is positive.
Yes. Okay. So the tail is going towards right, isn't it?
Yeah.
Since tail is going towards right, we say as positively skewed metric. It is skewed. Skewed because the graph is no longer mirror image. Graph is no longer mirror. Mirror image means what? If you put a mirror here,
same to same.
Same image will get this side, right? Normal. Okay. Earlier, what we did was like mirror image, more or less like mirror image. But now when you add these outliers on the right-hand side, it became non-mirror image. It has a long tail on the right-hand side. So right side is positive x-axis side. So we call this as positively skewed distribution. Positively skewed distribution. Had it been something like this, okay, so you have long tail here and then short tail. This would have been your negatively skewed graph. Okay, skewness for a normal is 0. Okay, negatively skewed, no skewed, 0, you'll get value 0. Here it is positively skewed because tail is going towards positive x side.
Yes.
Okay, it means there are more values on the right side. More values on the right side.
Okay.
Now you tell me, in this case, will median mode remain at same place?
No, sir. They'll shift.
Which side they'll shift?
Probably towards right.
Which one?
Right side, sir. Right side.
Median and min will shift to right side, but the mode will remain the same.
Mode will remain the same because mode is about measuring the height, right? This will be very small. So mode will remain same. Let's say if this is mode will remain here. But your mean and median will change. Which side will they go?
Towards right, sir.
Towards right side. Both will go towards right side. Okay. Now, which one will go faster? Which will be further away from mode? Both are going right side. Which will go more far? Mean will go more far or median will go more far?
Median.
Min.
Other day I showed you in Excel, I put the number and I showed you. When we added the number, mean, median, mode was all 555. But when I added 99, what happened? Okay, when we added 99, remember or not? In the Excel we did. Not only for you, for everyone.
I understand, sir.
Right? So you want to put it in the, why do you want to, waste your memory space in the laptop? Okay. So what happened is when we added 99, mean became 24 or something. From 5, it became 24. Median slowly moved right side. That's why we said that median is preferred because median is slightly impacted. Okay. So since if you add, since you add more and more values, outliers on the right side, mean will run faster. Mean will be somewhere here.
Okay.
Okay. And mean will move slightly,
Median will move slightly. Mean will move faster.
Median will move slightly, yes. Somewhere here. So this is another interview question. Okay. In positively skewed graph, which will be closer to mode? Mean or median?
Median.
Okay. median will be closer to graph. Now let's take example of this one, negatively skewed graph. Your mode will remain same, but here too, now since we are adding values to the left side, okay, your mean will be somewhere here and median will be somewhere here. Now, if you have tail on both sides, long tail, it is still a mirror image, no deviation. I mean, since you will not have any deviation. Positive, negative is deviation, right? So one side you have tail, other side you don't have. If both side you don't have, both side you have it, it's a normal graph, right? When you don't have one side tail and one side you have long tail, that's when we say skewed. Now, if you have, outliers on both the sides, it is like normal graph only. You get mean, median, mode at the center only. You get median, mode at the center only. But if this is short and this is long, that's when mean and median will start moving towards left. So in positively skewed graph, mean, median will both move towards right side or positive x-axis side. Mean will run faster. That's what we say. I use the same word, run faster. Mean will go further, much away from the mode, but mean will slightly move. So median will slightly move. So median is between mode and mean. Okay. Now, if negatively skewed graph again, mean and median will go towards left side. Okay, mean will run faster, median will go slightly. So median will be closer to mode, but on the left side of mode. In negatively skewed graph, mean, median are on the left side. And positive skewed graph, mean, median are on right side. You don't have to by heart. You saw, just remember this picture in your mind, you'll get it. I told you data is more towards right. Mean will run faster, median will run slower. So both will run towards right side, correct? Yep. But mean will always be closer to mode compared to median. Okay, so coming back here, now you tell me which kind of graph is this?
Positively skewed graph.
Positively skewed graph, right? Mode will be somewhere here, which is, I don't know, 15,000 something. Mean will be somewhere around 30,000. Median will be something around 20,000. Right? Okay. You have a long tail on the right side. So see here. You have used it, okay? Positively skewed graph, skewness will be positive value. Okay, see? Value is positive. Had it been a negatively skewed, you would have got -1. Okay? -1 means it is a negatively skewed, +1 means, and if it's perfectly normal, it would have been 0. Which is more skewed? Okay, we cannot see. We have to find the, calculate the skewness and you will get it. Okay. So that is skewness. Skewness talks about, okay, skewness talks about what? What does skewness tells you?
Like how much it is deviated from mirror image.
Normal image, normal deviation.
Yeah, exactly.
Okay, so higher the value, higher the skewness. So when you have two such distribution plot, you can find the skewness, and you can see whichever is the higher skewed is more skewed. More skewed means less confident you will be about the analysis. Okay, the accuracy will be lower, error will be higher. Now, what is kurtosis? Okay, shall I erase this?
Yes, sir.
Okay. Now, let's say this is a graph, and assume this is normal, okay? My drawing doesn't look like normal, but let's say this is normal. Now, I have one more normal graph, something like this. Okay. Now, if you see this, both are normal. So both will have same mean, median, mode. Yeah. With me?
Yes, sir.
Right?
Yes.
Both will have same mean, both will have same mode, both will have same median, and all the 6 values will be same. All the 6 values will also be same.
Yes.
Okay, because both are normal and at the same point, right? But then What is the difference between red one and the green one? Mean, median, both are same, right? So what is difference between red one and green one?
Minimum, maximum values are different. Basically,
Range.
Yes, minimum, maximum value are different. So what? So
sir, even the height is also different, no, sir?
height is different, count is different, but the value here is 5. See, in one case, 5 is repeating 50 times. In second case, 5 is repeating 30 times. So what? Here also 5 is repeating maximum times. Here also 5 is repeating maximum number of times. So 5 became your mode. See, height is frequency. How many times? And we are saying the maximum number of times is your mode. So let it occur 50 times. In green one, it was occurring 50 times. In red one, it is occurring 30 times. But in both the cases, 5 is occurring maximum number of times. No, the 5 is mode. Right? We in our calculation, we did not.
Okay.
We did not talk about the frequency. We're only looking at the x-axis.
Yes.
Not looking at the y-axis.
Okay.
Yes?
Yes, sir. Yes.
So both the case, it is mean, median, mode. Mean is 5, median is mode is 5. So both the graphs have same mean, median, mode, and all the 6 values are same. What is difference? Minimum values and maximum values are different. So deviation is different. Standard deviation is different.
Okay.
Okay. Standard deviation is different. Which has more deviation?
Red one.
Red one will have higher standard deviation. So if you calculate the standard deviation, red will have higher standard deviation, green will have lower standard deviation. So kurtosis talks about the shape of the curve. Okay. Skewness talks about the skewness. Kurtosis talks about the shape or the standard deviation. Okay. Higher the kurtosis, higher will be your standard deviation. Lower the kurtosis, thinner will be your graph, lower will be your standard deviation. So kurtosis talks about the width, okay, of the. Generally, 3 is supposed to be average kurtosis value. Okay, more than 3 or less than 3. Okay, so we have something called as plateau kurtic. Okay, wait. Kurtosis type. Okay. So see here. So the red one is called mesokurtic. Okay, mesokurtic means the standard deviation. Sorry, not standard deviation. Your kurtosis value is around 3. Okay, if the curve has kurtosis greater than 3, like blue is called platokurtic. Okay, platykurtic, flat. Green is called leptokurtic, thin one. So green will have lower kurtosis, less than 3 kurtosis value, and blue will have more than 3 kurtosis value. Okay, so in our case, tell me, is it which one? Lepto, LMP, lepto, meso, platy. It is the okay, it is here only, right? Sorry.
Green is leso, lepto.
No. In this one, what kind of curve is this?
6 platy.
Okay, it is platykurtic, yes. Okay, so that's about. Okay, so that is about the distribution graph. Everybody with me?
Yes, sir.
Yes, sir.
Okay. Now we talk about. So we have seen. Today we have seen only one graph, isn't it?
Yep.
Second graph is called scatter plot. Scatter plot is called XY plot. Okay. So in scatter plot, we plot 2 columns together. So in this case, they have sale price versus GR live area. Okay. Live area. And you plot. So live area column has values ranging from 0 to 5,000. And sale price has values ranging from 0 to maybe 8 lakh or something. It is, yeah, I think it's 800K or 8 lakhs. Okay, so now each point represents a value on both the column. So if you take about this one, this particular row has sale price of 6 lakhs and GR live area of 2,800 something. So you plot all the data here on scatter plot. So scatter plot is your XY axis, XY plot. Okay, it needs two values, one on x-axis, one on y-axis. The simple example is, let's say we have table where on one axis, one column, I'll call it as A and B. On B, okay, on A you have number of hours you study. Okay, and on B you have marks obtained, let's say. So if you study for 2 hours, you get 25% marks, 2 hours per week. If you study for 10 hours per week, you get 55% marks. If you study 35 hours per week, you get 65% marks. If you study 40 hours per week, you get 70% marks. How do you know? Maybe you have gone and done the survey of previous batch students. Okay, somebody who has already got the result, exam is done. So let's say you have your cousin or niece or somebody who's studying in class 10, and you want to predict how much marks your cousin will get, right? So let's assume that it depends only upon number of hours of study. So you will go and ask your cousin's senior, right? You will go and ask them, how many hours did you study? Okay, how much hours did you on average you studied per week? How much marks did you get? Okay, so you go and check with them, correct? And then you plot this graph. So one of them said studied for 2 hours, got 25. So now tell me, should we put hours on x-axis or should we put marks on y-axis?
Hours on x-axis.
Hours on x-axis?
Yes.
Why?
That is the basic parameter, no, sir. Depending on the hours, we are getting the marks. Like input output sort of thing.
So what? So what?
Basic reference value is hours. What I'm thinking is. So based on number of hours of study, your marks changes. That is output. First thing which is happening is time, which is in our hand. And second, based on that, how you are utilizing, you are getting the marks. So that is final outcome.
Okay. So say in mathematics, you can actually do anything anywhere. Okay.
Okay.
You can do anything anywhere. But
Okay.
it always follows some standard practice, isn't it? Okay.
Yeah.
Now, generally, if you see any mathematics equation, we say y equal to mx. Right? Now, why do you say x? We can say b equal to ma also, right? We can say p equal to mq also. You can use any letter, right? Anything is fine. See, it is anyway variable, right? If it is variable, you can use any variable as name, correct? But general tendency is that this is the standard we follow in mathematics, correct?
Yeah.
Y equal to mx. Okay, so x is what we need to give the value to get y, correct? So what is that we know? We know x and we are calculating y. We know x, we are calculating y. So in this case, what is that we are calculating and what is that we know? We know how many hours because that is in our hand. You can increase or decrease the number of hours, right? So if you try to compare this with this equation, this becomes your x, isn't it?
Yes.
X is something which we can control. which is in our hand. I can't control the marks that I get in 10th class. I can't control my performance in my interview. Okay, that is why I don't know this. I can't control this. It is not in my control. I can't control if I can clear the interview or not. But what can I control? I can control the parameters which will impact me to get job or get high marks. What is that parameter? Number of hours you study, number of hours you meditate, number of hours or maybe the books you study, right? So these are factors which in our hand. Number of problems I solve per day, right? If you solve 50 problems versus 10 problems, of course, if you solve 50 problems, your chances of getting higher marks is better. Doesn't guarantee, but of course, chances becomes higher. So that's why what we do is hours will be on x-axis, right? If you are following the math standard, you'll put hours. So you'll find 0, 5, 10, 15, 20, 45, 80, 80 hours like that. Let's say up to 100 maybe. Marks, again 5, 10, 15, maximum marks will be 100, isn't it? So here if you see 2 hours you studied and got 25%. So 2 hours, and this is 15, 20, 25, 30, 35, so on. So 35, let's say this is what you got. So this is how scatter plot is drawn. A value on the x-axis, value on the y-axis. So this one, 2, 25, 2, 25. Then 10, 55. Somewhere here you'll get. 35, 65. Something like this. 40, 70. Something like this. Okay, you might have more such values, right? Something could be here also, something could be here. Okay, so you are creating multiple such occasion, multiple such combination of x and y. Yes, this is what is your scatter plot. So this is the scatter plot. Okay, we are drawing between greater living area versus the sale price. Okay, so on x-axis you have greater living area. So something which area you want to live, you can choose, right? But sales, you're starting a shop, correct? And of course, we all want to get more and more sales. That's why you want to start a shop. Will you start your shop in your house or somewhere on the main road?
Main road.
Why? Because there you expect
yeah. Yes.
Right? So your sales is dependent. So you can't control this. You can't force people to buy from your shop, right? But you can control where you're putting your shop. You can control what you are selling, right? So this is what we call it as scatter plot x and y. Now, when you see this, okay, you see that mostly when you see as the living area distances increases, sale price also increases mostly. Okay, so here, okay, it is important to know the correlation. We find the correlation. Correlation, as the name suggests, right? Relation, correlation. That means two. It shows the relationship between two variables, your x and y. What happens when x increases? What happens to y when x increases? What happens to y when x decreases? Okay, if x increases, y also increases, and x decreases, y also decreases, we say they are correlated, and they are correlated positively correlated.
Direct relationship.
In the same direction. In this case, as the number of hours you study increases, marks obtained also increases. Same thing here also. Okay, so we are saying yes, they are correlated, and correlation is positive correlation. Positive correlation. As one increases, other also increases. Negative correlation. One increases, other decreases. Possible. Number of hours you watch TV versus marks you obtain. More number of hours you watch TV, less marks you will get. So that's a negative correlation. There is a relationship.
Yes,
Okay,
yes.
it's negative correlation. Okay, so negative correlation thing we should avoid because that is going to impact your marks. So if you watch more TV, you get less marks, right? So negative correlation. Sometimes you may not have any correlation. Okay, let's say I'm just giving an example. Number of hours you do swimming, let's say, doesn't impact. So we have people who did a lot of swimming also got less marks. They also got low marks. People who did not do swimming also got high marks and got less marks. Okay, so we say that there is no correlation. So you'll have three types of value here: positive correlation, negative correlation, or no correlation. You can also have strong strong negative, strong positive, weak positive, weak negative. Okay. If the dots, okay, we'll take one example here. Let's take this one. Now you see this. When x increases, y also increases. Correct? In first graph, x increases, y also increases. So we call it as positive correlation. Okay. Second graph, also you see x increases, y also increases. This is also positive correlation. Right? Here you see as x increases, y decreases. Correct? So we call it as negative correlation. Here you see, here also as x increases, as you go from left to right, y value decreases. So this is also your negative correlation. Positive, positive, negative, negative. Here you see dots are everywhere. Okay, right side also you have high, low value, left side also high, low value. So by looking at this, we cannot check, we cannot say if they are correlated or not. That means they're not correlated. Swimming example, number of hours you're swimming versus marks. You'll get something like this. That means swimming is not related to marks. It doesn't matter whether you swim or not, how much you swim does not matter. Okay. So, if you get something like this, it's called no correlation. We cannot say if there's a relationship between x and y or not. Now, if you see the dots are very closer to the line, if you draw a line which represents the entire dot, the dots are very closer to each other. Okay, that means this is called strong positive correlation. So when you calculate the correlation statistics, correlation value, okay, ranges from 0 is no correlation. So 0 to +1 for positive and 0 to -1 on negative. Okay, so we have value as magnitude. Value and magnitude. Magnitude, positive means both are increasing or both are decreasing. Negative means one increasing, other decreasing. When I say one is x and y axis, isn't it? So now if you calculate the correlation, if the value is between 0 to 0.5, typically when we say values between 0 to 0.5, we say there is no correlation. It's not possible to get exact 0. You might get 0.1, 0.2. Generally up to 0.5, we say no correlation. If you calculate the statistics, okay, 0 to 0.05 means no correlation. Again, see, there's no hard and fast rule. You can change based on your experience, but generally, this is what we understand. Between 0.5 and when I say 0.5, it is both plus and minus. Okay, so between plus and minus 0.5 to let's say 0.7, we call it as weak correlation. 0.7 to 0.8. Okay, minus plus both. We call it as moderate. Moderate is something between weak and strong, and more than 0.8 is strong correlation. Okay, so that's what it says. If you look at this graph here, dots are very closer to each other, right, on the same line. If you draw invisible line, dots are closer to the line, not far from the line. You got a strong. Positive because dot is moving in the positive direction. And they are following the same path, so it is strong. So you have strong positive correlation. Dots are far away from this imaginary line, so it is called weak correlation. Something in between would be moderate correlation. Okay, so moderate, weak, and strong correlation. So now when you go to the notes here, I forgot where I'm supposed to go. You're supposed to go to Kegel, right? Now you tell me, what do you think? Is it positive correlation, negative correlation here? Scatter plot.
Positive.
Okay, yes, it's positive. Definitely positive, but definitely not strong, right? Values are far away, right?
Yeah. Yes.
Maybe weak or moderate correlation you will get, but definitely not strong correlation, but it is positive. Okay, so similarly, you can create another graph. Total basement square feet versus sale price. Of course, higher the basement area, higher will be your sale price, isn't it? Here also is positive. Okay. Next one, categorical features. So what are categorical features? Categorical features are not numbers, right? They are groups. So we are looking at the count for each of the specific value. So let's say you have north, south, east, west. So you want to see how many values are in north and how many values are in south, quality, right? So how many product was in low quality, quality level 2, 3, etc. Okay, so if you see, of course, quality 10 has a wider spread. That means, you've got good quality product, right? So it says the sale price is between 12 lakhs, maybe 12 lakhs to 65 lakhs. Okay, your sale price. Okay, you have a 10 quality. Okay, so now these dots are called outliers. We discussed, isn't it? And this handle is your mean and max. So this is the mean value, this is the max value. Okay, mean sale price, maximum sale price under 10. So when you segregate, so you have an overall quality column, and you segregate them all the so quality column has values 1 to 10. Okay, this has values 1 to 10. Now I want to see how many people have voted. Okay, for quality 10. So you see that price range. Quality 1 has a price range of very small price range, right? But 10 quality has a higher price range here. So this is handle is your minimum value. Then the quartile 1 or 25 percentile. Then this is your median. Middle line is your median. That many people have voted for this. Median, then you have Q3, and then this is your maximum value. Then you can have outliers. So box plot is the only graph which will identify outliers. So you asked me a question, right? How to identify outliers the other day? I told you we'll wait. So the answer is there is no way to find outliers. You can do your own way. What we used to do in the previous company was we used to remove first 20%, last 25%. We used to focus only on middle 50%. Okay, so till here we would remove, and till here, these handles we will remove. We don't want to work on it. We will work on it. So that way, definitely your outliers will be in the left side, upper side, lower side, isn't it? So we are removing some data, and still we had a lot of data, right? So we worked on middle data so that we are comfortable that yes, outliers are gone. But if you want to capture the outliers, box plot, this is called box plot, isn't it? This is called vertical box plot. You can have horizontal box plot or vertical, doesn't mean, meaning remains same. So this box plot is going to give you the outliers. No other plot actually gives you outliers. You can decide what to do. You can decide to delete them. Okay, once you draw the box plot, you can see, and then you can decide to delete them. Hello?
Yes, sir.
Okay, so we'll stop here. Please have your code ready. Let me know if your code doesn't work when we meet tomorrow. Okay, and we'll continue discussion from here tomorrow.
Yes, sir.
Okay, sir.
Okay, everyone? Yes.
Yes, sir.
Yes.
Thank you, sir.
Okay. Yes,
Yes.
you're welcome. We'll
Goodbye.
see you. Bye.